Good morning, period 2 friends. Sorry I'm not here today. I'm in a meeting. Hopefully I'll be back before the end of class. But today we're going to do 3 notes pages. This page, writing equations from a graph, you should have from last class. You should have in your folders a page on vertical lines and horizontal lines. And then you should have a page on slope-intercept form. For this one, you're going to cut out these rectangles on the side. And then, once you have those cut out, your page should look like this. You'll just fold the 2 sides in at the bottom and cut it open so that there are little doors on here. So we're going to start with the slope-intercept form notes. I know this is a review, so I'm going to go through this kind of quickly. So when we're looking at slope-intercept form, the equation is y equals mx plus b. M stands for our slope, and b stands for the y-intercept. So your slope is, on a graph, we're looking at rise over run. And the y-intercept we learned about in Unit 2. Y-intercept is the point where our function crosses the y-axis. So when we're graphing an equation that's in slope-intercept form, our first step is to look at the equation and find the slope and find the y-intercept. Once we are able to identify those numbers, we plot the y-intercept and then use the slope to make more points on our line. So if we start with our first equation, this one says y equals x minus 3. This minus 3 at the end is my y-intercept. And the coefficient, the number in front of x, is my slope. I don't see a number here, so I know that means my slope is 1. So when I'm graphing my line, I'm going to start at -3 on the y-axis. That's B for this one. So my first point on my y-axis is at -3. My slope is 1. And if I wanted to write that as a fraction, I would write it as 1 over 1. So that means my rise is 1 and my run is 1. So starting from my first point, I rise 1 and run 1 and continue that pattern until I have a line that goes all the way across my graph. Once I've got all the points, I use my ruler to connect them and draw arrows at the end. In our next example, our equation is y equals 2/3 x plus 4. So my y-intercept is 4, positive 4 this time. My slope is this 2/3, the coefficient of x. So in this example, m is 2/3, b is positive 4. So when I graph my line, I'm starting at positive 4. And my slope says I need to rise 2 and run 3. But if I'm starting at positive 4, I can't rise 2. I should be going 2 up and 3 to the right. I can't do that, I would work in the opposite direction. And instead of going up 2, I would go down 2 and left 3. So this time I'm going down 2, left 3, down 2, left, oh, I can only fit 1 point on my graph, 1 other point on my graph. So I would use my ruler, make a line, draw arrows at each end. So this slope is still a positive slope. By going down and to the left, it's like making this -2 over -3. And a negative divided by a negative is still a positive slope. And if you think about what Slope Dude would say for this one, if Slope Dude was on our line, he would be saying puff, puff, positive as he's going up the line. So we know we have that positive slope that our equation said we need. In our third example, y equals 3x plus 4. My y-intercept is positive 4 again, and my slope is positive 3. So m is 3 and b is 4. So my first point is at positive 4 on the y-axis, and my slope is 3. To make this look like a slope, to make it look like rise over run, I need this to be a fraction, so it would be 3 over 1. So starting at my y-intercept, I need to rise 3 and run 1. Well, obviously that's not going to work. I can't rise 3. So we're going to have to do the same thing we did in our last example. And instead of rising 3 and running 1 to the right, we'll go down 3 and 1 to the left. And I'll continue that pattern until I run out of space. Once we've got all 4 points, use a ruler, make a line, make sure you draw arrows at the end. Our last example, this equation says y equals negative 1/2 x. So in this case, I don't see a y-intercept. What that means is that my y-intercept over here is actually 0. There's an invisible plus 0 happening. So if I'm adding 0, I don't need to write that down. And my slope is negative 1/2. So for this example, m is negative 1 over 2. Our b is 0. So I plot my first point at 0 on the y-axis. And my rise is negative 1, and my run is 2. So my rise is negative. That means I'm going to be going down 1, but my run still goes to the right. So starting from this point, I go down 1 and to the right 2, down 1 to the right 2. Once I run out of space on one side of my line, I would continue the pattern going in the opposite direction. So now I'll be going up 1 and left 2. So back at my y-intercept, I go up 1, left 2, up 1, left 2. Once I run out of space on my graph, I use a ruler, connect the points, draw arrows at the ends. In your notebooks, these notes are going to go into page 37. So we left this page blank the other day in class. So whatever page you left blank is where your notes are going to go. Now that we can graph in slope-intercept form, we can also write equations from a graph. These are the notes that we started on page 38. We did the point-slope form side last class. Today we're looking at the slope-intercept side. So if I'm writing an equation in slope-intercept form, I need to find the slope and the y-intercept of the graph. Once I know my slope and y-intercept, I write my equation in y equals mx plus b form. So I'll put 1, and then you can try the rest of these. So if I look at this first problem, I'm going to identify my y-intercept. That's the point on the y-axis. And my function crosses the y-axis right here at 1. So that means b, my y-intercept is 1. When I'm looking for the slope, I need 2 points on the line. So I've already got 1. There's another point right here at 2, -1. So my slope looks like I am going down 2 and over 2. So m is -2 over 2. I can simplify this -2 over 2 to -1. So when I'm writing the equation, I just need to fill in my slope. M is -1. Fill in my y-intercept. B is 1. So usually we wouldn't see this -1. The 1 would be an invisible 1, and we would write this as y equals -x plus 1. If my y-intercept was negative, I would have a minus the y-intercept at the end. But if my y-intercept is positive, it's always going to say plus. So try these other 3 problems. And then I'll check these hopefully when I come back to class today. But if not, we'll go over them the next time I see you. Our last set of notes is the notes about horizontal and vertical lines. This is going to be in your notebook on page, what are we up to? Page 39. So when we're looking at horizontal and vertical lines, the equations will always either have only an x or only a y. They don't have both x and y. In this case, our equation says y equals -2. On the graph, I know y equals -2 at this point right here. And if I'm looking for other places on the graph where y is -2, well, y would also be -2 right here. Over here, y is still -2. Same is true on the other side. Y is -2 over here. Y is still equal to -2 over here. If I were to label all of these points, this one would be 4, -2, 2, -2, -2, -2, and -4, -2. The y value is always -2. So this equation is a y equals equation. This says y is always -2. So if you have an equation that says y equals, this is always going to be a horizontal line. And we know that horizontal lines have a slope of 0. This is true always and forever. Our equation for a horizontal line will always say y equals a number, and our graph will always be a horizontal line that crosses the y-axis. If I'm looking at our next example, x equals 4. On my graph, I know that x equals 4 at this point right here. If I'm looking for other places where x equals 4, that's also true here. X is also 4 here. And on this side, x is still positive 4. If I had to label these points, this would be 4, 4, 4, 2, 0, 4, 0, 4, -2, and 4, -4. The x value of these points is always 4. That's what our equation says. X equals 4. X is always 4. So that makes a vertical line. So when we have a vertical line, we know the slope for that is undefined. Every vertical line has the same slope. They're all undefined. We just saw that our equation is going to say x equals a number. And when we make the graph, it is a vertical line that crosses the x-axis. So that's it for the notes today. I tried to make this as fast as possible, but it ended up being a little longer than I had hoped. Follow the directions on the agenda up on the board for your next steps today. Make sure you get your IXLs done. If you have time, you can go back to your IXLs from last class, the S20 and S22. Make sure you grab a copy of the homework. Everything you need for today, all the papers will be in your folder.